Welcome to my channel, The Proper Guidance. Here we are today to discuss about chapter number 6 of class 12 computer science, and this is all about searching. So in this chapter we will learn about linear search, binary search and search by hashing. Okay, so let's start. Introduction. We store many things in our home and find them out later as and when required, right? Sometimes we remember the exact location of a required item, but sometimes we do not remember the exact location, and in that case we need to search for the required item. A computer also stores lots of data to be retrieved later as and when demanded by a user or a program. Searching means locating a particular element in a collection of elements. Search result determines whether the particular element is present in the collection or not. If it is present, we can also find out the position of that element in the given collection. Searching is an important technique in computer science. In other design algorithms, programmers need to understand the different ways in which a collection of data can be searched for retrieval. So this is the very basic concept of searching. The name implies that you have to search something, that is searching. Now, first topic, linear search. Now, what do we mean by linear search? Linear search is the most fundamental and the simplest search method. It is an exhaustive searching technique where every element of a given list is compared with the item to be searched, usually referred to as key. So, each element in the list is compared one by one with the key. This process continues until an element matching the key is found and we declare that the search is successful. If no element matches the key and we have traversed the entire list, we declare the search is unsuccessful. That is, the key is not present in the list. Clear? This item by item comparison is done in the order in which the elements are present in the list, beginning at the first element of the list and moving towards the last. Thus, it is also called sequential search or serial search. So, for this technique we get two more names. One is linear search and sequential search and serial search. These three different names, but the same concept, same thing. Okay, three names of this type of searching. This technique is useful for collection of items that are small in size and unordered. This line is very important because you have to know now where to use that particular technique. So we use this technique where the collection of items are small in size and are unordered. Given a list, num list of n elements and key value k, algorithm 6.1 uses a linear search algorithm to find the position of the key k in num list. Num list is as a list of n elements. Now see, algorithm for linear search. Linear search, num list, key n. Step 1, set index equals to 0. Step 2, while index less than n, repeat. Step 3. Step 3 is if num list index equals to key, then print element found at position index 1, index plus 1, then stop. Else index equals to index plus 1, print search unsuccessful. Okay, so this is the algorithm. Algorithm means this is the way how to execute the program, the steps, okay, recipe of the program actually. Now see, example 6.1, assume that the num list has 7 elements. Here is the discussion with the help of a diagram. This is very useful now. So look at this one. Assume that the num list has 7 elements, those are 8, minus 4, 7, 17, 0, 2 and 19. So n equals to 7 here. We need to search for the key element, say 17 in num list. Suppose we are searching for the key element which is 17, whether the 17 is in the list or not. We have to search it with the help of linear search. We are discussing here. Elements in num list along with their index value. Now, index in num list, index will be started from 0, 7 elements are here. So, the list index will be go to from 0 to 6, 0, 1, 2, 3, 4, 5 and 6, and all the elements are the value. For 0 index, the value will be 8. For 1, index number 1, value will be -4. For index number 2, value will be 7. Index number 3, value will be 17. For 4, 0, 5, 2. For index 6, the value will be 19. Okay. The step-by-step process of linear search using algorithm is given in table 6.2. So, this is our ultimate table to find out how to use linear search for key 17 in the num list of table 6.1. See here, index 0, index less than n, index less than n. What is the value of index here? 0, 0 less than 7. Yes, num list index equals to key. What is the value here? Index number 0, the value will be 8. So, is it equal to 17? Because we are searching for 17. 17 is the key element. The key value is 17. It is a constant value. And we will check whether the value will be equal or not. 8 equals to 17? No. So, index equals to index plus 1. Move to it. Now, index value 1. Now, 1 less than 7? Yes. So, what is the value in number 1 index? Index number 1, the value is -4. Now, 4 minus 4 equals to 17? No. Again, index will be index plus 1, that is equals to 2. Now, here index equals to 2. 2 is less than 7? Yes. And what is the value here? The value is 7 here. So, 7 is equals to 17? No. Again, the value of index will be increased by 1, that is 3. And when the index is 3, whether the 3 less than 7? Yes. And now you go for index number 3 and the value in index number 3, that is equals to 17. Now, 17 is equals to 17. We are checking, we are comparing, right? So, 17 equals to 17. Yes. Observe that after 4 comparisons, the algorithm found the key 17 and will display element found at position number 4. Let us now assume another arrangement of the elements in num list as this one and search for the key k equals to 17 in num list. Then at the first position we can get it. Okay, first position. Now it is clear that the algorithm had to make only one comparison to display element found at position number 1. Thus, if the key to be searched is the first element in the list, the linear search algorithm will always have to make only one comparison, right? This is the minimum amount of work that the linear search algorithm would have to do. Let us not assume another arrangement of the elements that is equals to this one, that 17, the key element, is the last one. When the key element is the last one, then on a dry run, we can find out that the linear search algorithm has to compare each element in the list till the end of the end to display element found at position number 7. Thus, if the key to be searched is the last element in the list, the linear search algorithm will have to make n comparisons, where n is the number of elements in the list. This is in fact the maximum amount of work the linear search algorithm would have to do. Clear? So, let us now assume another case where the key being searched is not present in the list. It happens now. For example, we are searching for key equals to 10 in the num list, but there is no element 10 in the given list. Now, what to do? In this case also, the algorithm has to compare each element in the list till the end to display element is not found in the list. Thus, if the key is not present in the list, the linear search algorithm will have to make in n comparisons, right? This again is a case where maximum work is done. Let us now understand the program of a linear search. It takes a list of elements and what it do? It takes a list of elements and the key to be searched as input. It takes a list of elements and the key to be searched as input and returns either the position of the element in the list or display that the key is not present in the list. This is the main thing. Linear search is working like that. Now program, here is the programming code snippet, and let's say that please go through the entire program. If there is any problem, let me know. I will be there to clarify your doubts. with another class. And here is the complete program is given, as well as along with the output section is also here. Okay, so please go through and try to write down the program in your copy, or maybe you can execute it in your computer also. Okay, so next concept we are going to learn, that is binary search. Linear search is completed. After that we will now learn binary search. Consider a scenario where we have to find the meaning of the word zoology in an English dictionary. We have to, what do we search in the dictionary? In the first half, around the middle, in the second half. It is certainly more prudent to look for the word in the second half of the dictionary, as the word starts with the alphabet Z. On the other hand, if we were to find the meaning of the word biology, we would have searched in the first half of the dictionary, right? We were able to decide where to search in the dictionary because we are aware of the fact that all words in an English dictionary are placed in an alphabetical order. Taking advantage of this, we could avoid unnecessary comparison through each word, beginning from the first word of the dictionary and moving towards the end till we found the desired word, right? However, if the words in the dictionary were not alphabetically arranged, we would have to do linear search to find the meaning of a word, right? The binary search is a search technique that makes use of the ordering of elements in the list to quickly search a key. So, the binary search technique is used for the ordering of elements in the list to quickly search a key. Okay, for numeric values, the elements in the list may be arranged either in ascending or descending order of their key values. Okay. For textual data, it may be arranged alphabetically starting from A to Z or from Z to A. Okay. In binary search, the key to be searched is compared with the element in the middle of a sorted list. This is for sorted list, and it will check from the middle of the sorted list. This could result in either of the three possibilities. First one, the element at the middle position itself matches the key. It may match. This is one condition. Another point is that the element at the middle position is greater than the key, or the element at the middle position is smaller than the key. If the element at the middle position matches the key, we declare the search successful and the searching process ends. This is the most simplest case. But if the middle element is greater than the key, it means that if the key is present in the list, it must surely be in the first half. Right? We can thus straight away ignore the second half of the list and repeat the searching process only in the first half section. If the middle element is less than the key, it means if the key is present in the list, it must be in the second half. Okay, so we can thus straight away ignore the first half of the list and repeat the searching process only in the second half. This splitting and reduction in list size continued till the key is either found or the remaining list consists of only one item. If that item is not the key, then the search is unsuccessful, as the key is not in the list. Thus, it is evident that unlike linear search of elements one by one, we can search more efficiently using binary search, provided the list from which we want to search is arranged in some order. That is, the list needs to be sorted. If the list to be searched contains an even number of elements, the mid value is calculated using the floor division operator. If there are 10 elements in the list, then the middle position mid equals to 10 integer division. This is notation of integer division. 10 divided by 2, that is 5. Therefore, the sixth element in the list is considered the middle element, as we know that the first element in the list has index value 0. If required, the list is further divided into two parts, where the first half contains 5 elements and the second half contains 4 elements. It is interesting to note that the intermediate comparisons which do not find the key still give us information about the part of the list where the key may be found. They reveal whether the key is before or after the current middle position in the list, and we use this information to narrow down or reduce our search area, right? Thus, each unsuccessful comparison reduces the number of elements remaining to be searched by half, hence the name binary search. Let us now discuss the algorithm of binary search. Now, this is the algorithm. Please go through. Please go through. I think you can understand. And consider, I will explain this picture only. So consider a short list comprising of 15 elements are here. We need to search for the key 17 in num list. The first, middle and last element identified in num list along with their index value. So look at this picture. Index in num list. The first section is index 0, 1, 2, 3 up to 14 because there are 15 elements. Total 15 elements are here. Now when 15 elements are here, if we divide this section, the mid index number will be 7, where from index number 0 to index number 6, this is the first half, and from index number 8 to index number 14, this is the last half, means the second half, and index number 7 is the mid index of the given list. Now we will follow the technique of binary search. Binary, the name implies the two. Binary means the two, na? Double. So this is the technique. We have to search for the key element. Here is 17. Now see, working of binary search using steps given in algorithm. What the algorithm is written here, you please go through, try to write down this algorithm in a copy and then check it from the diagram here. It will be helpful for you. Now see, first at start 0, last 14, mid 0 plus 14 by integer division 2, that is 7. Okay, so it is completed. Iteration 0, 14, 7, and num list equals to k, not known, true. 17 equals to 17, mid 17 equals to 17, yes. At the mid index, the key value is matched with the given value, that is 17. So key is found, the search terminates here. Note that the algorithm had to make only one iteration to display element found at position number 8. This is because the key being searched is the middle element. When the middle element in the list, then the search is completed. But if we allow here the linear search, we have to go through for 8 searches now. But when we apply binary search, the searching time is very low here. So binary search requires only one iteration instead of 8 searches, which is followed by linear search. Middle value in the list. So this is the minimum amount of work. Binary search would have to do, confirm that a key is present in the list. Now let us search for key 2 in the list. Now see, 2 is the first element of the list, and if we allow the iteration here, we have the mid value 17, as 2 is smaller than 17. So it is obvious that 2 is in the first half section. We have to search for the first half of the list in the second iteration. We now consider only 7 elements, as 2 is smaller than the new mid value 7. We have to search for the first half of the remaining list in the third iteration. We now consider 3 elements. Observe that the number of elements in the num list is halved each time. When we have to, in the 3 elements, number half, then again you see that in iteration 1 to 7 elements in iteration 2 and 3 elements in iteration 3. In the third iteration it will be like this. Now see here, from this here, first, last 0, 14, mid 7, not known, iteration 0, 1, this one. 17 equals to 2, no. 2 less than 17, true. 0 less than equals to 14, true. So iteration 0, 6, 6, 7 equals to 2, no. 3 equals to 2, 2 equals to 2, yes. Key found, search terminates. Okay, so you people please go through. This is completely binary search, and this is the implementation using the programming code snippet. Try to execute in your computer, as well as try to dry run in your copy also. If there is any problem, feel free to ask me. I will arrange another class to clarify all your doubts. Okay, so please go through. My aim is to explain all the topic, okay, and programming part. After completion of this NCERT study material, I will go for the programs only. Okay, so applications of binary search. Binary search has numerous applications, including searching a dictionary or a telephone dictionary, finding the element with minimum value or maximum value in a sorted list, etc. Modified binary search techniques have far-reaching applications such as indexing in databases, implementing routing tables in routers, data compression code, etc. Search by hashing. This is the last point here. Search by hashing. Hashing is a technique which can be used to know the presence of a key in a list in just one step. Okay, so this is advanced mode, you can say. The idea is if we already know the value at every index position in a list, it would require only a single comparison to check the presence or absence of a key in that list. Hashing makes searching operations very efficient. A formula called hash function is used to calculate the value at an index in the list. Thus, a hash function takes elements of a list one by one and generates an index value for every element. This will generate a new list called the hash table. Each index of the hash table can hold only one item and the positions are indexed by integer values starting from 0. Note that the size of the hash table can be larger than the size of the list. A simple hash function that works with numeric values is known as the remainder method. It takes an element from a list and divides it by the size of the hash table. The remainder so generated is called the hash value. H element equals to element modulo size hash table. We can easily implement a hash table using a Python's list. Let us consider an empty hash table shown in 6.8. Look, an empty hash table with 10 positions from index number 0 to 9, value none, no value is here. Let us consider a list of numbers 34, 16, 2, 93, 80, 77 and 51. We can use the hash function remainder method explained earlier to create a hash table as shown in table 6.9. What we have to do? Look here, the first element is 34. Now 34 modulus 10 we will get 4. 16 modulus 10 6 and so on. Hash value will be 4, 6, 2, 3, 0, 7 and 1 and elements are 34, 16, 2, 93, 80, 77 and 51. Hash value along with the element. After computing the hash values, each element is inserted at its designated position in the hash table. Each element is inserted at the designated position in the hash table. Now, hash table generated for elements in table 6.10 index and value. Index and value. When index and value will be there, we get this one. We get what? 80. What is the value here first? 80. Why 80? 80 because this is 0. 0. So, first one is 80. After that, hash value 1. 51 is here, 80 and 51. After that 0, 1, 2. 0, 1, 2, element will be 2, take it. After that modulus value 3, so element will be 93 here. After that 4, this is 34 here. After that 5, is there any value 5 here? 5 none, no value is here, no modulus as 5, so write down here none. And when we get 6 here, write down the value 16, and when we get 7 here, write down 7 here, 77. And if there is any 8 value, no 8 value is here, so none, no 9 value is here, 9, and these are already taken, 80 and this thing. Okay, now to search for a key, we can calculate its index using the hashing function and compare the element at that index with the key to declare whether the element is present in the list or not. This search operation involves just one comparison and hence the same amount of time is always required to search a key irrespective of the size of the list. So this is the advantage of hash table and searching by hash. Okay, search by hashing, this is the main advantage. Same time will be needed here. So you people please go through. Here is also another program. Go through. Any problem, ask me. I will clarify again. After that, output is also given. Collision. What is collision? The hashing technique works fine if each element of the list maps to a unique location in the hash table, right? When we are taking the modulus, maybe same modulus value you can get. Now we have to write down the element. While applying the hash function say list I modulus 10, two elements 16 and 26 would have hash value 6, right? This is a problematic situation because both the hash value is 6 here. Now we have to write down the element because according to our definition, 2 or more elements cannot be in the same position in the list. This situation is called collision in hashing. We must have a mechanism for placing the other items with the same hash value in the hash table. This process is called collision resolution. Collision can be resolved in many ways, but it is beyond the scope of this book to discuss collision resolution method. If every item of the list maps to a unique index in the hash table, the hash function is called a perfect hash function. If a hash function is perfect, collision will never occur. Apart from modular division method, hash functions may be based on several other techniques like integer division, shift folding, boundary folding, mid-square function, extraction, radix transformation, etc. Again, it is beyond the scope of this book also. The time taken by different hash functions may be different, but it remains constant for a particular hash function. Thus, the advantage of hashing is that the time required to compute the index value is independent of the number of items in the search list. It is to be remembered that the cost of computing a hash function must be small enough to make a hashing based searching more efficient than other search methods. Okay. So this is all about the chapter number 6, that is searching. We have completed it. Next day we will learn chapter number 7. Till then, take care and thank you for watching.